Hello, this is Kuntal Chakraborty, Assistant Professor of Electrical Engineering Department, Greater Kolkata College of Engineering and Management, JIS Group. I am just going to discuss the pin description of 8051 microcontroller. So this is the pin diagram of 8051 microcontroller, where we are seeing that we have different pins from 1 to 8, that is used as port 1, and we have RST pin, and here we have port 3, that is started from 10 to 7 pins, and it has another functions RxD, TxD, INT0 bar, INT1 bar, T0, T1, and WR bar, RD bar. So this is basically a multiple functions we have for port 3, and here we have XTL1 and XTL2, in which the crystal oscillator is connected to provide the operating frequency of 8051 microcontroller, and we have ground, 20 number pins is basically ground, and here from 21 to 28 there is a port 2 that can be used as a general port, as well as it has a multifunction. Basically this can be used as higher order address. And here we have PSN, ALE and AA signals into 29, 30 and 31 pin, and from 30 to 39 is a port 0, and it has a dual functions also that can be used as multiplexed lower order address data bus, and number 40 pin is VCC. So this is a pin structure of our pin diagram of 8051 microcontroller, and I am just going to discuss every pins of 8051 microcontroller. First is a port 1, that is started from pin 1 to pin 8. Now this port 1 includes pin 1.0 to P1.7, P1.0 to 1.7. so this can be used as input as well as output. And pin number 9 is a RST, means a reset pin, and reset pin is used to reset the 8051 microcontroller, and by this is a active high signal we have to provide to it to reset the 8051 microcontroller. And port 3 here, that is pin number 10 to pin number 17, that is port 3, pin number 10 to pin number 17. And here we have dual role of this port. That port can be used as input as well as output, and all of them has these pins has alternative functions, and these alternative functions of this port pins: P3.0, that is RxD, P3.1, that is TxD, P3.2, that is INT0 bar, P3.3, that is INT1 bar, P3.4, that is T0, P3.5, that is T1, and P3.6, that is WR bar, and P3.7 is a read signal. So I'm just going to explain all the signals, that is RxD. RSD is actually the serial asynchronous communication input by which the reception of data that can be made, and TxD is a transmission signal by which the transmission can be made in 8051 microcontroller, and INT0 is a external interrupt lines that is connected with a pin 12, and INT1, that is an external interrupt also, that is connected with a pin 13, and in pin 14 and 15, that is T0 and T1, this is the input of the counter 0 clock and input of the counter 1 clock, and these two pins that can be used as timer counter. And here we have the pin number 16, that is the WR, that is basically used as a write control signals, means any kind of write operations is happening, means that signal that will be active. This is active low signal, and that will generate at the time of any write operations. And pin number 17 basically used as a read operation. This is also active low signal, and whenever we require to read any anything from the memory, then the read signal that will be active. And these are the alternate signals of the port 3. Next is a pin 18 and 19, that is XTAL2 and XTAL1, in which the crystal oscillator is connected. So basically in 8051 microcontroller, 4 megahertz to 30 megahertz frequency we actually provide. So this kind of crystal oscillator that will be connected in between XTAL1 and XTAL2 to provide 4 megahertz to 30 megahertz frequency. Now pin 20, that is basically the ground pin. Port 2, that is started from P21 to pin 21 to pin 28. So pin 21 to pin 28 is a port 2, and that can be used as a higher order address bus also. Means this port 2 that can be used as input output port, and whenever we want to connect any memory, so addressing needs at this time, this port that can be used as A8 to A15, that is means that can be used as higher order address bus. Pin 19, that is PSEN signal. This pin is used to enable the external program memory. If we use an external ROM for storing the program, then a logic 0 appears on it. This is active low signal, and if you want to access the external ROM, then obviously this PSEN bar signal that should be active. Pin 30, that is a ALE, that is address latch enable signal, that is active high signal. That this latch enable pin is used for the multiple memory chips. Then this pin is used to distinguish between them, as well as the address and data bus, that is multiplex lower order address data bus, that can be distinguished by using this ALE. And next one is a pin 31, that is a EA, and by applying logic 0 to this pin, P2 and P3 are used for data and address transmission with no regard to whether there is internal memory or not. Means if it is active at that time, if the program is written into the internal memory, so that will not be accepted. Only the outer means the ROM that is connected with the memory and program written into it, that will be accessed only. So this is the enable access by which we can access the ROM that is connected connected externally with the 8051 microcontroller. So this is a pin EA. Now next one is a pin 32 to 39, that is port 0. So port 0, here in the diagram, port 0 is basically used as a simple port, as well as that can be used as a multiplex lower order address data bus. So now basically this port generally is used as to connect to input output devices, as well as we can use these as a lower order multiplex address data bus, and this address and data bus that can be separated by using the ALE signal. So I already discussed, by using ALE we can select address as well as data bus. If we give a ALE signal as 1, means active high signal, then that will behave like a address bus, and if it is 0, then that will behave like a data bus. Next is a VCC, that is a power supply that is connected with the 8051 microcontroller. So these are the pin diagrams of 8051 microcontroller. So I already discussed every pin of 8051 microcontroller and their work. So that's all. Thank you.